Hello guys, welcome to CS50 Problem Set 3 Runoff Walkthrough Tutorial and Solutions. So first, we're going to talk about the runoff program, the distribution code, the pseudocodes, and we're going to pause the video before we move into the solution sections. So first, for the runoff program, you want to key in /runoff ABC, which is the candidate name. Then you're going to key in the number of voter. For each voter, they have different ranking for the candidates. So in this case, this is just an example. So the program is going to go through a certain algorithm to find out which is the highest voted candidate. So from here, the runoff program, the concepts we're going to look for the first thing is the ranking for the rank 1. So you might see here there are 3 voters vote for A for the rank 1. So there are 3 voters for from B, so this B 3, and the C is 1. So from here we can see that there are no majority votes. This is even and this is the least vote. So for this runoff, we're gonna eliminate one candidate, the lowest vote candidate. So for example, for this case is 1. So we're gonna recalculate it. Then you can see from this voter, so initially he voted for C, but after we eliminate C, we'll go to A. So that's why there's another additional 1 vote for the A. So from here, we can see that clearly that A has the higher majority votes. So we can see what is happening behind the program. So first, we have several functions here. So we're going to go through several steps to find out the last winner candidate. So we have 6 functions: vote, tabulate, print winners, find means, is tie, eliminate. So the vote function is basically just to summarize all the data here to this table here. You can see here voters, there are 7, so 0 to 6, there are 7. Rank, there are 3 candidates, so 0 to 2, there are 3. So once we assign, for example, this A is 0, B is 1, C is 2, we can just simplify them into this table. Then you can see the A, B, C, so it's 0, 1, 2, 0, 1, 2, and this is 0 to 1. So this is a simplified versions. So from the vote functions, we're gonna have another functions called tabulate. So tabulate is basically outdated. As I mentioned just now, we will only focus on the rank 1. So just take the rank 1 and put it here. So you can see the A is 0. So there are 3 zeros, so there are 3 here. So B is 1, so there are 3 1 and there's 3 here. And C is 2, so 2 is only 1, so that's why 1 is here. So you can see that the default is all eliminated is false, means they are all available in these elections. So after we tabulate all the informations here, we're gonna find is any candidate has more than half of the votes. So total voters have 7, so any voters has more than 3.5. So you can see there are 3, so there are no majority voter here. So here we're gonna find the minimum value here. So you can see C has the least vote count. So we can determine that min is equals to 1. So from here we can go through is tie. Is every candidate remaining in the elections has the same number of minimum vote. So you can see 1 only have in the C here. So then the answer is no. So we go through eliminate. So eliminate, we can see that all are still false. What we're gonna do here is to change the false to true. So after that, we already eliminate this to change this into true. So we go through another last step is to reset all candidate vote count to 0. So after that, we're gonna compile again. So you can see here there are 1, 2, 3, 4. So since number 2 is already being eliminated, so we can take this. A is 4 count, B is 3. So C is 0 and this is true. So is there any candidate has more than half of the votes? Yes, it's A. So A is the winner here. This is how the program works behind the scene. So to help you guys understand more, I will create a flowchart. So you can see here start. So the user can key in the number of candidates, the name of the candidates, then the voter, number of voter. Then we're gonna input also the each voter's vote candidate by rank. Then we're gonna go through the vote here. So it's just to put all the information into this table, tabulate. So just to fill out things here, tabulate, yeah, here, something like that. So is there any winner? Is any of them has majority vote? So no. So go through the find min. You can see 1 is the min. So is any all the candidate has the minimum votes? No. So go through this step. Eliminate any candidate who has the minimum of vote. So basically we just change this to this. So reset all, so sorry, before this step, we're gonna reset first. Then we're gonna tabulate again. Then only we change this into here. So this is the rough flowcharts for this program. So we're gonna explain about the distribution code. So you can see here, this is the library, and this is a constant. Max voter is 100, max candidate is 9, and the preference for J, preference for the voter I's. So basically, this is like a 2D matrix. So you can see for this example, so we decline a 2D array, integer preference 2, 3, and this is the value here 1, 2, 3, 1, 2, 3. So you can imagine the 2D array is like a box. So preference 0, 0 is equals to 1, which is this. 0, 1 is 2, 0, 3 is 0, 2 is 3, and so on. So this is 2 row, 3 columns. So this is row and this is column. So he will go from the top to the bottom. So next we go through the type def structs candidates. So each candidate has a name, vote, and eliminated. So this is a size of the candidate. So you can see here this is the same thing roughly. So in the CS50 exercise, this person has a name and a number. So this is basically just put here, and this is the size of the struct. Then how we assign the data to here, basically just add dot name, dot number, and put what we're gonna assign to here. So it's gonna be the same thing for this. So you can see here the array of candidates max. So this is the size array as I mentioned here. So this is a global variable, voter count, candidate count, and this function prototype is where our exercise come from. This is what we all need to be completed. So just for example, for the candidates, for example, a candidate name Alice, vote 0, eliminate false. So this is how we assign maybe a data here. So next we'll go through integer mains, int, argc, and string argv. So from here, checks for invalid users. If argc is less than 2, the program gonna print out this statement. So it means that when a user key in /runoff, without anything here. This is arg1, argc1. So this is not what we want. The program is gonna print in this, and you can see here return 1. The architectures of this program, we know that this is the error 1, that user didn't key in any candidates. So this is, I believe, the CS50 already explained. There are 1, there are 2. This is how uh, we record and track what is the error in the program. So next we're gonna go through populate array of candidates. So candidate count equals to argc -1. Basically, it means that when you key in /runoff Alice Bob, so these 3 terms is argc3. So just to find the number of candidate, what we do is just -1 here, argc -1. Then we already found the number of candidates. So next, if the candidate count is more than max cat candidates, so we'll print out something. If the user key in too many candidates, which is out of our range, the program gonna prop this to the user. So next is the structs, how we assign the data into here. Just do a loop to the candidate count and .name, .void, .elimate. This is how we assign. So why this .name has a special indication here? So as I mentioned previously, you can see if you put directly I here, it will just go into this /runoff. What you want is the Alice. So for example, you can imagine I is 0. So 0 plus 1 is 1. So it's Alice, then board, then so on. So that's the reason we put I plus 1. So example, you can see Alice dot false assigned by do this dot name dot void dot eliminated. So next we're gonna go through voter count, get integer. So if the user key in too many voters, the program gonna prop the user is, for example, maximum number of voter is 100. So you can see return 3 to indicate what error that the program run up. So from here you can see keep querying for vote. There's a loop on the voter count. There's another loop for the candidate count. Basically, it's something like loop here and loop here. So this is actually where the user key in the rank here. You can see here the get string is here. So if the user key in something like, you see Alice Bob and suddenly there's a Charlie, so the program gonna prop in invalid vote. So you can see return 4. Okay, so that's it. So for the next code, this is the whole picture for the main point, the main mid of the program. You can see we'll keep holding runoff until winner exists while true. So this will always run. Then first we're gonna tabulate, calculate vote given remaining candidate. So you can see here, after we go through here, we go to the tablet here. Then next we go through the print winner, which is this. If won, then we just go direct here. If didn't won, if won, you can break out from this loop. If no, you can go through the mean here, which is this. So after we find the mean, is it the tie is a mean? So it's something like, is every valid candidate in the elections has the same number of vote, which is the minimum vote? If yes, we're gonna print every candidate which are not eliminated. Then we're gonna break again out from here. If no break, we're gonna go through the next, which is the eliminate. So just eliminate the members who has the least vote count. Then in this line here, you can see reset vote count back to 0. So we're gonna reset all the candidate vote count to 0. So as this. So basically this flowchart help you to understand easier. Okay, so we go to the pseudocodes. First, we go through the Boolean vote. So find for the name, how they prefer us. If not, don't update. False. Preference is actually something related to the RAM, the ranking, candidate name rank. Okay, so go to the tablet. As I say, tablet is just to take the first rank, just to put to here. So update the vote count for non-eliminated candidates. Prefer for highest preference. Print winner. First, we're gonna find the half of the vote count. If the candidate more than a half, return true, else false. So you can see here any candidate more than half, no. So we're gonna find the minimum vote, so which is 1. So next we're gonna find Boolean is tie. We're gonna compare whether the find out how many non-eliminated candidates. For example, here are 3. So how many candidates with the least vote? There's only 1. So compare is same, true, else, false. So you can see here there are 3 false eliminated candidates. They only got 1 candidate which has the least vote count. So we can prove that both are not tally. So there are no tie for this case. After that, the last step is to eliminate. So basically just eliminate the non-eliminated candidates or candidates who has the least number of votes. So for example, this, just change the false to true. So we go to the first vote functions. So before we input any value here is basically just empty. So because we didn't update any value. So what we need to do is to assign value here. So the vote functions will only start from here. It means that we have the value of I and j. So I and j is actually given, that we no need to have any worry about it. So string a name will be given. So the user key the name will be here. So vote function is implemented in here, is within I and j loop. I and j is given. So what we're gonna do is basically just preference 0, 0, 0. This is candidate. This is candidate. So you can see here from these distribution codes, we already have a table here, A, B, C, and 0 and false. So how gonna, how to update the preference? Basically, you see this function, we just do a for loop through the candidate count. So we just compare whether the candidate with the name, with the name that the user key in, this name, which is this function. So check whether is the candidate name here, is the name that the user key in. If they are tally to each other, this is what we must have in our functions. Basically, it means that preferer I and j equals to I. So I is actually represented by the candidate. So this is the very important point for this function. Return true, else return false. So you can see that the red color is actually not completed, that you need to be figured out by your own. So this is all you can just direct paste into your code. So tabulate Tabulate is actually just take the highest ranking here from the 0, just update the vote count here. So you can see here, update the vote count for non-eliminated candidates. The vote count reverses to higher preference with both conditions. So just now we already have the value here. You can see here, preference 0, 0 is 0, preference 0, 1 is 1. So we have all this value here. We're gonna put it into here. So basically, to take all the vote count here, we're gonna have a loop here. All right. So and a loop here, because if one of the candidate is already true, then we'll go to the second rank here. So we're gonna have a 2-array loop here. You can see there's a voter count, then another candidate count. Because if they are false, then we're gonna move the second rank, then the third rank. So this red color is you need to fill it out. So this is very important code here. If the candidate, we can just put preference ing dot eliminate, because we must check for non-eliminated candidate. That's why we must make sure is false. Then only that we update the vote count. So if not false, we're gonna just break it out or what. So for example, for this case, so it's 0, 0. So there is true, is false here, which is correct. So we're gonna update 1 here. So this is gonna be 1. 1 is 2, 3, then later here, then later 2 and 3, then there's only 1, then 1 is here. Okay, this is, I think, is slightly complicated, but try to understand this code. I think once you understand the previous this, you understand this 2D array matrix. Next, we're gonna go through the print winner. So to find the winner, we just have to find the vote count first. For example, here there are 7. So by common sense, to win the vote, the elections, we're gonna have set 7 divided by 2, 3 by 5. So if each of the candidate has, any of the candidate has more than 3 by 5 votes, is gonna be the winner of the elections. So you can see here, this I leave it to you, which is I think quite direct. And for loop using the candidates, so the loop will go through here. So if the candidate count votes is more than the 3.5, then we're gonna print the candidate name. Okay, this is quite easy. Find minimum. So first we must understand where is this come from. So the find means is actually at here. So the find minimum value will use at the type and also the limit. So to find the minimum value, we need to, you see this table, basically we just have to do a loop here to find which value is the smallest. So only checks for limit candidates, limit is false, track and compare, mean is found. So first for these functions, we have to, declare a integer, lowest votes equals to voter count. So voter count is, for example, for this example is 7, because there are 7%. So we're gonna do a loop to the candidate count, and we must make sure they are false, and we're gonna compare 1 by 1, this and this and this. So if the 7 is smaller than the lowest votes, which is 3 is smaller than 7, then this lowest vote will equal to 3. Then if the 3 is smaller than 1, so it will become 1. So this is how we find the lowest vote count. Then we must remember to return the lowest vote. Right? So you can see here, because we must return a value, so this value will go to the minimum here. So after that, other function can be used this value. So is tie function. So you can see here, this is just an example. This is not tie because you can see not the same value. You can see this is actually tie. So what I want to show you is we must make sure this is false. This true is not included. So it means that we only checked for the candidate and made it eliminated false. So how are we gonna check whether is it tie or no? So basically, if the number of non-eliminated candidates, for example this, is equal to the number of candidates with the lowest vote count, this. So if the number of candidates is the vote count with the minimum vote count is 2, and the eliminated candidate false is 2. So both are equal, it means they are tied here. So we have 3 sections here. First, we will decline an integer non-eliminated equals to 0. Same, we're gonna go through a loop here for the candidate to find it one by one. So if the candidate's eliminated is false, for example this one, we'll plus 1. So for this case is 3. Same concept here. Decline integer equals to 0. A for loop towards the candidate count. If they are true, they are false here. So if the candidate vote is equals to minimum, so you can see this only got 1. So plus value by 1. So from this example is only 1. Sorry, this is, for example, this is 3 and this is 1. So if the number of non-eliminated candidate equals the number of candidate with the lowest vote count, return true, else return false. You can see 3 is not equal to 1, that means it's false for this example. So for the eliminate functions, you can see here the lowest vote count is 1. It's false. We just have to change to true. So minimum vote count is known, only checked candidates I dot eliminates equals false with minimum vote count. So this is quite direct. Basically, we have to do a loop through the candidate count. Okay, then we have to see whether they are false. Okay, then if again they have the minimum vote here, because we already know the minimum vote count, so just change this status to true. Yeah, that's it. So remember the red color, you need to complete it by yourself. So that's it. Now pause the video and try solving it before continue to the solution section. Okay, welcome back. So we'll go into the solution section. Okay. So that's something reconnecting. It's okay. So, okay, let's see. This is a library that we have. From here, I think we just start here. Please wait for a while. So we can notice that try to run the star 50. Sometimes I face some problem here also. And also try to test your codes here. It's really helpful. Sometimes I tested before I found any error here. All right, let me go into my right we are here. So for my codes, I include another library called string.h because for the string compare, and this is the constant, the 2D matrix, the struct, the size of the candidate, and this is the global variable voter count, candidate count. So this is function the prototypes. Okay. So if argc less than 2, we have another statement print out, find the candidate count, -1. So this to if the candidate count more than max candidate, prop this, assign data into the candidates to get the number of votes. If the number of votes more than a certain amount, prop this statement. Then this I and j given, this is where your vote function here. So this is what I read now. I already know the I and j here. So if any name that the user key in, which is not inside the candidates, will prop this invalid vote, return for, and this whole thing is so about true, tabulate, print winner, find mean, tie, eliminated, reset all the vote count back to 0. So this is the vote functions. So just do a loop toward the candidate count to compare, string compare whether the user key in the name is it the name that we previously put the first one /runoff. So if correct, so we're gonna add the rank into the 2D code here, the 2D table. So return true or else false. Then we go to the tablet. So tablets, we go through 2 times, for example, something like this and this. So you can see there are I loop and j loop for the voter count and candidate count. So you notice that the candidate here inside there's a 2D array here matrix. So element equals to false. If false is means non-eliminated candidates, then we pass the vote number into the table. So after we get the, for example, you can see we get the rank 1. I think we go to here. So we get the rank 1, then we just take this number, we break out from this j, then we go to another I. For example, if here this is false, this is true, then we just skip the first one, go to the second one. Then after that, we just break from the j here, we go to the end. That's why there's a break here. And we go through the print winners. So basically the majority equals to voters count divided by 2. Then we go through a for loop to the candidate count. If the candidate vote is more than majority, then just print the name, return true, else false. And for the find mean, we just take a decline variable equals to the vote count, which is the highest vote count. So just compare with the do a loop for the candidate count. Make sure they are non-eliminated equals to false, equals to false. Then if the candidate vote is less than the voters lowest votes, just equals here. So at last, from this number will be from the highest vote count into the lowest. So after that, remember to return a value here. Then we go to the is type here. So is type have three mini functions here. First, we're going to declare an integer equals to 0. Then we count the number, do a for loop to the candidate count. We find how many candidate emitted equals to false. We record it down. Then we do another same concept, decline integer equal to 0. Do a for loop, make sure the candidate is false, and checks whether their vote count is equals to minimum. Then we plus the value here. Then we compare these two integer whether they are equal. So to do that, we just have to check if non-limit equal to count candidate lowest, return true, else return false. So at last, we go through this function void unlimited integer. So we just do a for loop. If the candidate is unlimited false, if the candidate vote count is equals to minimum, we just change the candidate I equals to true. So let's test something. Okay, let's check something whether this is correct. Just do something like dash runoff A, B, and C. So there are 5 A, C, B, A, C, B, D, C, A, B, C, A, and C, A, D. So it's A. So it's the same result as here. Alright, so this is how I resolve the runoff assignment. So that's it. Thanks for watching and see you next time.